You're listening to Electrician Live with your host, Paul Abernathy. Well, hello everybody. Welcome to another episode of Electrician Live. My name is Paul Abernathy, and welcome to the podcast. On today's podcast, we are going to talk about a specific wiring method. It's probably the most commonly used wiring method out there. It's easy to bend, so you kind of understand where we're going now. It is lightweight. It's very versatile. It does add physical protection, and it is also probably one that is misunderstood when it comes to some of the applications, like whether or not you can put it in the ground or not, whether it can be in wet locations and all that. So if you haven't figured out, we're going to talk about electrical metallic tubing today, EMT. Now remember, EMT is a tubing system. It is not a conduit. It is indeed a raceway because it defines it under 358.2, which is the definitions. It defines it as a raceway. Whereas an auxiliary gutter, for example, is not a raceway, whereas a wireway is a raceway. So we have to understand the distinction. But inside of the definition of the different types of wiring methods, when it's a raceway, it will define it as a raceway. So 358.2, for example, definition tells us that EMT is a unthreaded, thin wall raceway of circular cross-section designed for the physical protection and routing of conductors and cables. Yes, you can put cables in EMT for those that ask. There's direct permission there. And for the use as an equipment grounding conductor when installed utilizing appropriate fittings. So obviously, 250.118 allows the EMT to be used as an equipment grounding conductor, provided all the fittings are done right, everything's torqued right. Okay, you can do it. Many engineers will still specify to put a wire type equipment grounding conductor in there based on the size of the overcurrent protected device in 250.122. And that is fine, but you can use the actual tubing as an equipment grounding conductor as long as you do everything right, and it will be no problem at all. So understanding the scope, we have 358, the article dealing with EMT, is three parts to it. You have a general part, you have an installation part, and then you have what's called a construction specification, which is pretty much covered by the manufacturers. Not a whole lot that you have to do there. But you understand that part one, there's a scope, and it lets you know that 358 that's dealing with EMT in this article covers the use, installation, and construction specifications for EMT. So we're going to be covering it, as well as associated fittings that you would use with the EMT. Of course, you have definitions of the .2, and there was a little change in the 2020 code that I just want to make you aware of, that it says, hey, this definition in this section for this EMT, for example, is used within this article. Obviously, it's 358. It deals with EMT. But it also says that it also governs the definition of EMT used anywhere else in this code. So whether or not you're using it up in a hazardous location and it permits EMT to be used, or wherever somewhere else in the code it makes reference to EMT, the definition of EMT is going to be very much remaining in the .2 section of Article 358. So it's just kind of reminding you that. So what is the definition of EMT? It is an unthreaded, thin wall raceway of circular cross-sectional design for the physical protection and routing of conductors and cables, and for the use as an equipment grounding conductor when installed utilizing appropriate fittings. 358.6 talks about listings. So listings is going to remind us that EMT, factory elbows, and associated fittings all are required to be listed. When we say listed, they're evaluated by a third-party NRTL, Nationally Recognized Testing Laboratory. It could be UL, it could be ETL or Intertech, it could be FM, it could be CSA. However, whatever that manufacturer chooses to have that product evaluated, they all get constructed based on a base ANSI UL standard, which has nothing to do with the third party. The third party just identifies that it was made to a specific standard, and they allow you to put their mark on it saying, yes, we've inspected it. We know that they produce products to meet that standard that it's designed by. So you could have a UL ANSI standard, but then you have Intertech or CSA or Met Labs, for example, actually do the third party, and they put their stamp on it, and it's just as equivalent as any of the others, and that's all governed by OSHA. Okay, so listing means that those elbows, those factory elbows, those EMT, and the associated fittings have all been listed and evaluated to be in conformance with their design standard. Now, you move on to part 2, which is installation. And this is where we get to the infamous uses permitted, uses not permitted. So dot 10, that's dot 10 section of 358 deals with uses permitted. Dot 12 deals with uses not permitted. So it kind of gives us an understanding. Now, obviously, uses permitted is a lot larger than the uses not permitted section. So let's look at the uses permitted. And there's an A and a B, and there's a C, and there's a D. Okay, and they all kind of work together for you to understand how you apply for the EMT. And again, many people like EMT because it is thin wall. It's easy to bend. You can use a mechanical bender. When you start getting trade sizes 2 and larger, many people will opt to a hydraulic bender because we just don't have enough butt to get the bend accurate and do it without potentially kinking it. But you can buy factory elbows if you want and do it that way. A lot of people take pride in how they can run their tubing and not have to use couplings and all that. You know what? For me, as long as I get the job done, I don't really care. But a lot of people take pride in how they can run their EMT. So anyway, all of those have to be listed. Now let's look at the first one under uses permitted, and that is A, and that's dealing with the exposed and concealed. So EMT obviously is permitted to be in exposed environments as well as in a concealed environment, a very versatile wiring method we have with EMT. And just remember, EMT is a tubing. It is not a conduit. IMC, intermediate metal conduit, rigid metal conduit, PVC, polyvinyl chloride conduit, those are conduits. We're talking about a tubing. So if you learn anything here today, you will stop calling EMT a conduit and make sure you know that it's a tubing. It's an extrusion process, okay? So now that we got that out of the way, for those that still call EMT a conduit, why is that important? Because there's areas that in the code which talk about conduits that will not apply to tubing. If it refers to it as a raceway, then it can apply to an EMT tubing. It can apply to an RMC, rigid metal conduit, that type of wire method. So it's important to understand the difference. It's no different than we know that MC cable is a cable and it is not a conduit. It is not a tubing. It is a cable. So it has different rules that apply. So just want to kind of knock that out of there. All right, so when we are doing exposed or concealed work under 358.10a, me and you are doing this installation, and we want to use EMT, here's what it says. The use of EMT shall be permitted for both exposed or concealed work for the following. And it gets you have a subdivision, a 1, a 2, and a 3 item. And it gives you the 3 things, and it says, okay. And it starts out by just giving you the basic exposed or concealed applications. It says, number 1, I can install EMT in concrete. I can install it in direct burial with the earth or in areas subject to severe corrosive influences. I can use it in any of these locations where installed in accordance with 358.10b. And of course, 358.10b is talking about corrosive environments. So we're just kind of looking at where we're at here, whether it's exposed or concealed. I'm okay with EMT in either one of those applications. I'm okay in concrete. I'm okay in direct burial in the earth. And if I'm dealing with a severe corrosive influence application, as long as I follow the application of 358.10b for corrosive environments, I'm good to go. Okay, we're just kind of laying the land here. The second item says, you know what, I can use EMT in a dry, damp, or wet location. Of course, if I'm in a wet location, it's all relevant to the type of fittings I use to maintain the ratings. So it'd be compression type fittings and things like that. Dry location, probably just going to be normal set screw type fittings. All these type of things are normal. But the point here is that EMT is permitted. It's a very broad allowance here for you to use EMT, whether it's a dry, damp, or wet location. Okay. And then the third one says, you know what? I can use EMT in any hazardous classified location as long as it's permitted in the other articles of the code. And so, for example, if Article 501 for hazardous locations, Class 1, whether it's Division 1 or Division 2, if it mentions the use of EMT as an allowable wiring method, then you're okay. Everything is perfectly fine. Same thing for 502 for Class 2 and 503 for Class 3. Okay, so it's making reference and saying it's perfectly okay. It's perfectly permitted for you to use it in those environments as long as those other articles permit the use of EMT. Okay. Now let's talk about B, which is corrosive environments. There's a number 1 and there's a number 2. So there's a subdivision 1 and 2. And it says these items, It says galvanized steel and stainless steel EMT elbows and fittings. That's the header for B1. It says galvanized steel and stainless steel EMT elbows and fittings, and it should probably say and associated fittings, shall be permitted to be installed in concrete, in direct contact with the earth, or in areas subject to severe corrosive influences where protected by corrosion protection and approved as suitable for the condition. Now, incidentally, let's talk a second about galvanized steel. There's a website you can go searching for on Google it. It's Steel Tubing Institute, which gives you a lot of really good information on their industry. And when I used to work with NEMA, we worked a lot with called 5RN, and that was all the raceway guys. And you learn a lot from those folks. They're very knowledgeable about their products, and that was the beauty of working with NEMA, is be able to learn from all these different sections within NEMA that deals with manufacturers. And what they'll tell you is that the galvanization process, for example, let's just use galvanized steel, is obviously a ferrous raceway, and it is being utilized, and it has protection that's inherent to its production under its UL standard. Okay, it's ANSI UL standard. So many people will complain that you can't put EMT in the ground. They'll complain that you can't use it in concrete. And the reality is, check with that manufacturer and determine whether or not their product is approved and suitable for a condition of use, especially if it's dealing with a severe corrosive influences. But usually anywhere else in the country, it already comes with a protective coating on it that's required, part of their production process, and that can go into the ground, and it doesn't need anything supplemental at all for that. Now, if it becomes a severe corrosive environment, and a lot of jurisdictions will want an additional supplemental protection, but off the bat, typically galvanized steel or stainless steel already come approved for that application to be installed directly in the ground. Whether you see it or not, it's irrelevant because it does typically have that listing on it. Now, let's move on to the second one, and that is, what about aluminum EMT? Very common. It's making a big surge out there. There's a couple companies that just produce aluminum EMT. It's a really light. It bends well, and it is still EMT. It's still an EMT product, tubing product. But let's read what it says here in 358.10b2, because we're in the corrosive environment part of Section 10. And it says, supplemental protection for aluminum EMT. It says, aluminum EMT shall be provided with approved supplementary corrosion protection where encased in concrete or in direct contact with the earth. So people say you can't put aluminum EMT in the ground. Not true, but you will need some approved supplementary corrosion protection. Now, it uses the word approved, so that means it's approved through the AHJ. So whatever you use, whether it's a wrap or a paste or whatever you do, if you're going this route with an aluminum EMT, just make sure you get the approval and the blessing of the AHJ. I also tell people, go on and contact the manufacturer of the aluminum EMT and ask them what type of supplementary protection do they recommend, because there is a great chance that they have done the testing and they have selected a manufacturer's type. And at the end of the day, if you get a manufacturer telling you to use this and you take this to the AHJ, the AHJ looks at it and says, well, hell, that's what the manufacturer recommends. That seems like it's going to be approved to me, and it just makes your job so much easier. Don't be afraid to reach out to the manufacturers. That's what they're there for. They'll give you that guidance. All right, now we move on to item C, or subdivision C, which is talking about cinder fill. And it says galvanized steel, which is probably the most predominant EMT you're going to find. Galvanized steel and stainless steel EMT shall be permitted to be installed in cinder concrete or cinder fill where subject to permanent moisture when protected. Okay, so there's a protection requirement. When protected on all sides by a layer of non-cinder concrete at least 2 inches thick, or when the tubing is installed at least 18 inches under the fill. So we have cinder fill. If you're going to install these raceways, that's galvanized steel or stainless steel EMT, then you can install it in it, but it has to have at least 2 inches on all sides of non-cinder concrete, kind of like an encasement, if you will. But the other alternative is to simply put it at least 18 inches under the cinder fill, and then you're okay and you're fine with using galvanized steel or stainless steel EMT in that application. Okay. The next thing is dealing with wet locations. So this is real important because it states, even though we can use EMT in a wet location, as we saw, in a dry location and a damp location, this says addressing more the supports, the bolts, the straps, the screws, and all that kind of stuff. It says, okay, we get that you can use EMT in these locations, wet location, doesn't matter, but the weakest link is what's supporting it. And so it says all supports, bolts, straps, screws, and so forth shall be of the corrosion-resistant material or protected against corrosion by corrosion-resistant material. So just make sure your straps, your bolts, your screws, whatever you're using that you're working with the EMT, you do a lot of effort to make sure that the EMT is okay to be somewhere. But how much time do you really spend or devote to the straps or the bolts or the supports that are actually supporting the EMT? Are they okay to be used in a wet location environment? And so that's something that you have to take into consideration, and that's what's addressing here. So that's the general A, B, C, and D. Now we move into E. And there's been a slight change for this. It's new here in the 2020 code, and that is physical damage. It says stainless, steel and stainless steel EMT, okay, shall be permitted to be installed where subject to physical damage. Now, you're going to see here in a minute that it's not going to be subject to severe physical damage, but it's okay for physical damage. Now, there were many folks that submitted public inputs to try to get a definition of what physical damage was versus severe physical damage, and we just never got there. We never could get a full description or definition of what we were doing. We think it's best to be left to the AHJ. But I'll give you an example of something in my mind that's the difference between physical damage and severe. So let's say I have a parking garage and I'm running EMT down on the wall. And it's in an area where cars are going to be moving in and out. To me, that area is subject to severe physical damage. A car running into it, parking area. All right, but if I run it high and I put it on the lower part of the ceiling and run it across there, then that is okay. That's not really subject to severe physical damage. It's subject to physical damage. It might be antennas whacking it or something like that. So I use that as a broad example. If it looks like it's going to be in a location that literally could get damaged by something running into it, again, not trying to think beyond the scope of reality and common sense. The only important thing is that most places that we install stuff is where it's subject to physical damage. It's fairly light damage, contact damage, things like that. When I see something severe, it's in an application or location where it's literally could be a severe something running into it, things like that. You have to use your best judgment. Obviously, working with the AHJ, authority having jurisdiction is going to have to help you with that. But the good news for 2020 is that at least EMT of the steel or stainless steel is okay for physical damage protection, okay? Just not severe physical damage, okay? And with that transition, we are literally done with the uses permitted. So now we're moving into the uses not permitted. And that is, again, dot 12, so that's section 12. And that is pretty common through most of the wiring methods. Dot 10 is going to be uses permitted. So if you're preparing for an exam, just kind of remember that. Dot 10, uses permitted. Dot 12, uses not permitted, especially when you're dealing in the Chapter 3 wiring method applications. All right, so let's look at the uses not permitted. It says EMT shall not be used under the following conditions. And there's two conditions here. The first condition says we're subject to severe physical damage. So we've already defined that. Now we defined it in the scope of our conversation, but there is absolutely nothing that defines the difference between severe versus normal physical damage. You're going to have to make that determination. Now, me as an inspector, when I look at it, if it's at a certain position where it is subject to things hitting it, then I might go to the severe. If it's on the wall in an area where people just make traffic, me and you walking, and it's in a corner, or maybe it's behind something that it would have to get hit anyway, like say there's a bollard there and you'd have to literally hit the bollard before you actually hit the wall where the EMT is, then I'm not going to elevate it to severe. Okay, that's just me. Until we get a full definition of physical damage versus severe physical damage, until we get that, I don't think we're going to be able to do anything other than that. In a quick look again, just so for my own edification, I'm looking in the definitions, and I'm pretty sure it's not there, and I see nothing to do with physical damage or even the reference to severe physical damage. Somebody could submit that for 2023, but it has been submitted multiple times. And my recommendation is somebody needs to submit something that says mechanical protection and try to utilize that in some applications. Anyway, that's for another time, another topic. But use is not permitted. It's not permitted, EMT, subject to severe physical damage. Now, number 2 says it's not permitted for use for the support of luminaires or other equipment except conduit bodies no larger than the largest trade size of the tubing. So if I have a trade size 3/4 and I have an LB conduit body, for example, and that conduit body's entries are 3/4, then it can support that conduit body. Okay. So use is not permitted with EMT. It's not to support luminaires or other equipment except for conduit bodies. And again, the conduit body, the entries can't be larger than the largest trade size of the tubing that's supplying the actual or that's permitted to supply the LB or whatever other LR, LB, whatever, for the conduit bodies. Okay. Next is dealing with 358.14, and that is dissimilar metals. It says where practicable, in other words, where you can do it. Some cases you can't do it, but where practicable, love that word, dissimilar metals in contact anywhere in the system shall be avoided to eliminate the possibility of galvanic action. Okay, so this is pretty simple in the concept of making sure that we have an aluminum not coming in contact, for example, aluminum EMT coming in contact with a copper plumbing line. I mean, just kind of a good example of that. But it goes on to tell us this. It says, while you're thinking of all that, it reminds you that stainless steel and aluminum fittings and enclosures shall be permitted to be used with galvanized steel EMT. So I can use stainless steel and aluminum fittings and enclosures that are stainless steel or aluminum fittings. I can use that with galvanized steel EMT. So that's important to remember, okay? Now, it says, and galvanized steel fittings and enclosures shall be permitted to be used with aluminum EMT. We're not subject to severe corrosive influence. So again, got to pay a lot of attention to what we consider severe corrosive influence, not just corrosive influences. It's a severe corrosive influence, okay? And where would this take place? This might take place if you're doing something in a building with certain chemicals. Maybe, again, everybody up in 680 seems to freak out about pool houses. So that might be considered severe corrosive influence to some people, not to me, but it is to some people. So you want to be careful on how you do it, but this gives you the way to be able to use stainless steel or aluminum fittings with galvanized steel EMT, okay? And I'm able to use galvanized steel fittings and enclosures shall be permitted to be used with aluminum EMT, okay? Now, notice how it goes the back way there. It goes the other direction. That takes us to something that was added here in the 2020. It says stainless steel EMT shall only be used with the following. Okay, so remember we talked stainless steel fittings and aluminum fittings can be used with galvanized steel EMT, but this is a one-way street because I'm only allowed to use galvanized steel fittings, okay, with aluminum EMT. So what about this stainless steel EMT? We're not talking about the fittings now. We're talking about the stainless steel EMT itself. It says they can only be used with the following. Number one, it can only have stainless steel fittings. Okay, it can only have stainless steel boxes and enclosures. Okay, number 3 says, okay, steel galvanized, painted, powdered, or PVC coated, and so forth, boxes and enclosures when not subject to severe corrosive influences. Okay, so that means that I can use stainless steel EMT, and that would be the steel, whether it's galvanized, painted, powdered, or PVC coated, Rob Roy, that type of thing. I can use it with boxes and enclosures, but I can't do it if it's a severe corrosive influences. Normal applications outside in the rain or somewhere like that that's just outside doesn't immediately raise flags of that being considered severe corrosive influences, okay? It might be a corrosive influence outside, but that's under corrosive environments, but that is not what I consider severe corrosive influences, okay? There's a reason why they have this severe in front of it, all right? And then, of course, the fourth one says, again, stainless steel EMT shall only be used with the following: stainless steel, non-metallic, or approved accessories. Okay, so obviously it's okay to use it with stainless steel, but I can also use it with anything that's non-metallic, provided it's listed to be used with an EMT of the stainless steel type. And of course, there are different types of accessories that I could use with stainless steel EMT. And again, you're also looking for those accessories to be approved for use with stainless steel EMT, okay? So now let's talk a little bit about sizes. What is EMT available in? You're working on it every day, and you're thinking, okay, what sizes are available for the EMT? So 358.20 is dealing in sizes, and there's a minimum and a maximum. So EMT, smaller than metric designator 16, which we usually use the trade size, which is trade size half. Many people call half inch, okay? Says it shall not be used. So it can't be smaller than trade size 1/2 for EMT, okay? We typically don't use the metric designator 16, but its equivalent is trade size half. And many people call that half inch. It just kind of works out that way, but it's really referred to as trade size half, okay? And then there is an exception. The exception says for enclosures, for enclosing the leads of motors as permitted in 430.245B. So that's an exception, and that's making an exception to the requirement for the minimum size EMT, okay? Now, what about the maximum size? How big does the EMT go up to? Well, the maximum size EMT shall be trade size 4. And if you're looking at the metric designators, it's 103. So we typically use trade size 4 is the maximum size. So when you see EMT, it's usually going to be in a scope from half trade size all the way up to trade size 4. And it'll be available in half, 3/4, trade size 1, or people refer to as 1 inch, 1 1/4, 1 1/2, and it'll just move its way up that scale there. Okay. And of course, you have an informational note there that just reminds you. It says 300.1C for the metric designators and trade sizes. These are for it says these are identification purposes only and do not relate to actual dimensions, okay? So that's why we use trade size. So we refer to that as trade size 4, and people call it 4 inch, but the trade size 4 doesn't necessarily, the designators, they're for identification purposes only. Again, they do not necessarily relate to the actual dimension of the products, okay? We're just so used to calling it. And so, of course, when we do raceway fill, we're in Chapter 9, Table 4, and Table 5. We're dealing with the different types of raceways and the values, approximate area, and all that type of stuff that we're dealing with that, okay? But we just simply go and choose the size that's given there. Trade size 4, trade size 3, trade size 2, and whatnot, and we work from there. We don't overcomplicate it. Now, 358.22 is the number of conductors. So this is an example where we talk about the code, and we say, if you remember the basic layout of the National Electrical Code, chapters 1 through 4 apply generally to all electrical installations. And then we got chapters 5, 6, and 7, which can modify or supplement anything from chapter 1 all the way up to chapter 7. So we've got that overlapping there. And then, of course, we have informative annexes and various tables. Now, as far as the tables are concerned, when a code reference makes reference to the table, then it is very much applicable. Otherwise, it's just really good information. But where the code makes a reference to that table, then we know that we can utilize that table. Now, where you get the guidance on that for folks that didn't grasp that, I guess, or something like that, then you want to look at 90.3, and there's a nice figure there, 90.3 in your National Electrical Code, that kind of explains that tables are applicable as referenced, okay? So I cover that in my video series when I talk about Article 90, and I explain how that structure, what the mandatory rules, permissive rules, explanatory material, and I go over all that in extreme detail, units of measure, you understand a hard conversion versus a soft conversion. Go look at that series. I think it's available over on our Patreon page. You got to be a subscriber to get it, but it's up there, and I talk about all those little nuances in Article 90, and you need to know them, okay? All right, so let's talk about the number of conductors. It says 358.22, number of conductors, and we're talking EMT now. It says the number of conductors shall not exceed that permitted by the percentage fill specified in Table 1, Chapter 9. Now, if you're not familiar with Table 1, Chapter 9, you need to get yourself familiar with it, because anytime that you're going to be involved in a raceway fill calculation, unless where all the conductors are exactly the same size, then you get to cheat and you go to Informative Annex C. And again, that only applies if all the conductors are exactly the same. So it's kind of a cheater, if you will. And you can do that. Just remember that that doesn't equate for adjustment and corrections. That's just telling you how many I can put in a raceway and not exceed the 40% fill for over 2 conductors. Now, Table 1, Chapter 9 gives us the values, and it's the percentage of cross-section of conduit or tubing for conductors and cables. And there's a lot of notes that are associated with it. All these notes are very much applicable to the table, okay? These are not informative notes. These are not informational notes. These are actual notes that are going to apply. So if I have 1 conductor in a raceway, then I can fill the cross-sectional area of that raceway up to 53%. If I have 2 conductors in a raceway, I can fill it up to 31%. And if I have over 2, I can fill it up to 40. Now, I get a lot of questions from people about the 2 conductors. Why is that at 31, but over 2 allows me to go up to 40? And the 31 has a lot to do with the jam effect and the way the conductors lay in the tube as they go around 90s and bend and things like that, and how they lay. Whereas usually when you have over 2, you come into what's called a cradle effect, and it just allows the conductors to stack. So a lot of that history has to do with those cross-sectional areas of fill, and that's where it kind of came from. Don't overly dwell on that, because you're never going to find any of that information on an exam. It's just good information, but a lot of this has to do with informational notes that are underneath Table 1 and talks about jamming and all that kind of, and that's where we derive the values in the cross-sectional area that you're not to exceed. So in our case, we're dealing with EMT. So we're dealing with, if we're over 2 conductors, we're not going to exceed more than 40%. Okay. Now, if I'm putting an NMB or an SER, or I'm putting a tray cable, for example, inside of an EMT, I'm perfectly allowed to do that, because you saw back in our description, or definition, I guess, of EMT, it allows for conductors or cables to be in there. So it's perfectly fine, but you're going to have to treat that cable as if it's a single conductor. And you get all those rules in the notes. So that's example is be note 9. And that talks about how you do it. And again, if it's any long elliptical cable, then it tells you that you use the long dimension, and you have to basically replicate it as a single conductor, and it goes in there, and it's 53% fill, okay? The interesting thing is if I have 2 cables in there, then they are both considered a single conductor, so then it kicks me to this table where I have 2 conductors, and then I can't exceed 31%. If I had 3 cables in there, and I did my calculation as a single conductor and did the sizing, then all of a sudden 3 singles in there means it's now over 2, because you treat a cable as a single conductor, and then I can't exceed more than 40%, okay? And I can tell you the cables are pretty big, so you're going to have to do the math, and you're going to have a big raceway. So it pretty much governs itself, but I wanted to make you aware of that when we're dealing with the number of conductors, okay? Now, it also goes on to say under 358.22, the next paragraph, it says, cables shall be permitted to be installed where such use is not prohibited by the respective cable articles. So if a cable article says you can't put it in a raceway, then you can't do it, okay? But it's very much one of those applications where you can, unless the cable referenced article says you can't. For example, a lot of people will tell me you can't put NMB in a raceway. And that's not true, because 334 specifically has an application where one example would be a type 1, type 2 construction where you could put NMB and run it in that type of construction if you ran it in a raceway that is permitted for that type of construction, rigid, intermediate, whatnot. It specifically allows that. So it's not prohibiting you running the non-metallic or SCR or whatever inside of a raceway. In many cases, obviously now that EMT is utilized for physical damage protection, I might be utilizing EMT to protect my cable assembly. Most of the time, people are going to use Schedule 80 PVC to do that because it's cheaper, it's lighter, and but you can. And I just want to make sure you understand you can. And again, it also says, look, it says the number of cables shall not exceed the allowable percentage fill specified in Table 1, Chapter 9. Okay, so be aware of that. If I put one cable in there, Chapter 9, Note 9, it'll tell me in the notes, it'll tell me that I'm going to treat that as a single conductor. And then if it's only one cable in there, I don't want to exceed 53% fill. So it all works together, this beautiful thing that we have in Chapter 9, Table 1, but just understand all those notes, okay? But yes, unless the specific article on a cable type prohibits the use of putting it in EMT, you certainly can put cables in EMT, okay? The other question that people ask me all the time is, what about securing the cable to the enclosure? What if it's run inside of an EMT, then I can't secure it to the enclosure? And you don't have to. If you're running an individual cable, then you're going to have the problem of having to make sure that you secure it to the enclosure because you run the risk of damaging the cable as it enters the box. But if it's raceway to raceway, or box to box via a raceway, then you don't need to secure the cable to the box. There's no chance of damaging the cable because it's entering into the box through the raceway. I get a lot of questions about that. All right, let's talk about bends for a second. Big topic. I get a lot of questions about people with bends. So 358.24 bends, how many can you have? You probably all heard the old concept of how many bends I can do, but this is dealing with bends, how they're made. And listen to this. It says, bends shall be made so that the tubing is not damaged and that the internal diameter of the tubing is not effectively reduced. If you bend it, if you kink it, you've reduced it, you've messed it up, you've damaged it, get another stick and start over again. You screwed it up. Now it says the radius of the curve of any field bend to the center line of the tubing shall not be less than shown in Table 2, Chapter 9 for a one-shot or a full shoe bender, okay? So this is if you're bending them in the field and you're making bends. People do things like shepherd bends and all these type of bends. You want to make sure that the bend, whatever you're doing in the field, you're trying to maneuver the bend to get to how you need to get it to the box. You just want to make sure that the curve of any of those field bends down the center line of the tubing is not less than shown in Table 2, Chapter 9. So that takes you back in there. And there you can actually see that there's a column that is talking about the one-shot or full shoe benders. And those are the inches values that you have there. And it's just reminding you it can't be less than that value. It can be, that's if you're trying to make something really tight, okay? And that's for in the field. Not going to be an issue if you're buying factory bends, right? This is ones that you're making in the field. Okay. Usually not an issue unless somebody gets all, I've actually seen EMT people try to bend it really tight at the end. And of course, that's when you're going to get into this value and you're going to have to go to Table 2 of Chapter 9 and look at the one-shot full shoe bend and make sure that the point where the bend starts versus the point where it ends down the center line is at least the radius of the values that are given in Chapter 9, Table 2. Okay. Down that center line. So the next bending we're talking about is 358.26. Now, this is the one that has to do with the number of bends between pull points. And here's what it says, number in one run. Now, the one run is between pull points, okay? So important to understand what we're talking about, not the summation of an entire installation. This is between your pull points. And here it says, there shall not be more than the equivalent of 4 quarter bends, then quarter bends being 90-degree bends. 90 times 4 is 360. So it just reminds you, we all talk about this in the industry. We say no more than 360-degree bends between pull points. For example, conduit bodies and boxes. A conduit body can be utilized as a pull point, and from there back to the actual box, I just have to make sure that I don't have more than 360 degrees worth of bends. Now, that means you have to add offsets, the percentage of degree offsets. You have to do any 90s, any 45s. All of those have to be added up, and you can't exceed 360 degrees worth of bends between your pull points, okay? Which could result in you having to add another pull point. Now, that's interesting because if you add a pull box, or you're trying to suffice this rule so you're not breaking the 360-degree rule for bends, and you put a box in. If you put that box in, and it's to be a pull box, and you're going to have to make sure you size that box properly. A lot of people just put a little box in there to try to meet this rule, but again, if you put it in and it's a pull box, then you have to size it, and again, if it's pulling straight through it, then the conductors are 4-gauge and larger, then it's going to kick you into 314.28, and that's going to be straight as 8. Angles are 6. So 6 times. So if I had a trade size 2 coming in and it's just simply passing through and going out the other side, then I have to make sure that I follow those rules. If this, again, if the conductors are 4-gauge and larger. And so in that case, we say it was trade size 2 times 8, and it's 16 inches. So it would have to be a minimum of 16 inches from the point where the box ends, starts on one to where it exits the other side, the opposite wall. And so straight as 8. If it was going in left side and going out the bottom, then that kicks us into an angle pull application, and it's 6 times, and you also have to make sure that it's at least 6 times the largest raceway between the raceways that contain the same conductors. In other words, coming in one and then going out the one at the bottom. All right. Anyway, we cover that in our 314.28 class video, so hopefully you go back and watch that if you don't understand how to do box fill sizing and pull calculation sizing of boxes and all those goodies. Go back and watch that. All right, so just don't exceed more than 360 between bend points, pull points, okay? Now, let's talk about reaming and threading. Now, 358.28 is titled Reaming and Threading, and you remember EMT in the definition says an unthreaded thin wall, okay? So, number one, A says reaming. All cut ends of EMT shall be reamed or otherwise finished to remove outer edges. Basically, when you make a cut, you want to make sure that whether you stick the end of your sideman clines in there or side cutters, or whether or not you have a special device to do this or not, or whether or not you put your screwdriver in it and you ream it around, and whatever you're doing, you got to remove those burrs, okay, those rough edges. It's going to rip up your insulation when you're pulling conductors, and ultimately, because it is a metal tubing system, it's going to affect potential insulation resistant tests probably down the road if you start damaging that insulation. Insulation is the only lifeblood between the actual conductive medium and the metal tubing, which could cause you a lot of problems down the road. Okay, so we want to make sure the integrity and everything's done. Threading, it just reminds us again, we're at subdivision B. It says, by the way, EMT shall not be threaded. Okay, so there is an exception to that rule where it says EMT with factory threaded integral couplings complying with 358.100. And of course, that is construction requirements, 10-foot sticks of EMT, and it comes from the manufacturer that way. Okay, that is an exception. Most of the EMT does not come that way. It comes simply cut on each end, deburred already, and you buy couplings and fittings and you put it all together, you're good to go. Okay, so this is just reminding you the general rule is EMT is not to be threaded, although there is an exception if a manufacturer does make an EMT, but they have to be factory threaded and it has to contain an integral coupling on the end, okay, in order to beat that. Most do not do that, okay? Now, that's common with rigid, that's common with intermediate, and they'll put the coupling integral to it on the end, and then usually put a cap on the end to protect threads, but that is not what we get in EMT. It's not out of the question, but it's not under the general rule. You don't thread EMT. It's just too thin. It have to be done by the manufacturer's requirements. All right, the next thing we're going to look at is we've done all this stuff up to, but now we need to understand how do we secure and support EMT. So we're at 358.30. Now here's another tip. .30 throughout most of the wiring methods in Chapter 3 deals with securing and supporting. So it stands to reason here when we're dealing in 358 that dot 30 is also covering securing and supporting. Okay, so how we put this up. So let's look at it. It says 358.30, securing and supporting. It says EMT shall be installed as a complete system in accordance with 300.18. So you're completing it box to box. Okay, you have a fitting, goes to a box. You have the tubing, it goes 10 feet, goes to a coupling. You put another piece of tubing in, you keep on going, and you end in another box. Okay. All right, that's a complete system, and that's what 300.18 is talking about. Now, we're not talking about applications where we're using small pieces for physical damage protection. We're talking about when you're installing something as a complete raceway system, as 300.18 gives us guidance on, and it shall be securely fastened in place and supported in accordance with 358.30A and B. So it's not A or B, it's A and B. Now, A deals with securely fastened, B deals with supports. So let's look at it here. So EMT shall be securely fastened in place at intervals not exceeding 10 feet. Okay. It says, in addition, each EMT run between terminal points shall be securely fastened within 3 feet of each outlet box, junction box, device box, cabinet, conduit body, or tubing termination. Now, this one's interesting because while we have to secure it every 10 feet, when we go into a box, whether it's an outlet box, junction box, we have to make sure that we add a support so that it is supported, or I guess I should say securely fastened, the EMT, to the surface within 3 feet of that connection to the box, okay? Or that connection to a junction box or device box or cabinet, what have you. And then you could go 10 feet to the next support, okay? All right, so that's how we utilize it that way. Now, there is exceptions to that rule, and these exceptions to that rule have to do with the fact is, what if I can't get that securement or that fastening in place within 3 feet? And here's what it says, exception number 1. It says fastening of unbroken length, okay? So there's no coupling in there. Fastening of unbroken lengths shall be permitted to be increased to a distance of 5 feet, where structural members do not readily permit fastening within 3 feet. The greatest example that I can give you here is when you're installing in a parking garage, and underneath it's a concrete parking garage, and you have the support structure beams that come down. And because of the spacing, you have a box that's on a beam, and the other beam might be further away than 3 feet, and you just simply can't get a support on it. Well, if you don't have a coupling in it, it'll allow that piece of EMT to go all the way up to 5 feet away from the box before you can put that supporting and securing, I keep saying that backwards, securing method there to hold it. So this allows you, if you're dealing with that, and because the structural members do not readily permit you to be able to do it at 3 feet, this will allow you to increase it. So I can go from the box over to the next supporting member if it's not more than 5 feet away. Okay, so this gives me some relief from the 3 foot rule. Okay, the next one is exception number 2, and it says, okay, for concealed work in finished buildings or pre-finished wall panels where such securing is impracticable, it says unbroken lengths without couplings of EMT shall be permitted to be fished. So there's occasions where I can get into the wall and I can drop an EMT down, and I just can get it down and I can put it in a box, but I am not going to be able to meet the securing requirement within 3 feet. I'm just not going to be able to do it. It's in the wall. I'd have to open the wall, and it would just be impractical to do that. And what's the point? So this is allowing you, kind of like fishing cables in a wall that we probably talked about in other articles. This is kind of the allowance here for that. But the general rule is you can you secure EMT at intervals not exceeding 10 feet, and you make sure that you secure it within 3 feet of the box, junction box, cabinet, conduit body, or other tubing termination. And we know that we do have an allowance if a piece is unbroken and I need to go up to 5 feet to put that secure fastener in place because I don't have the ability to do it within 3 feet. and I'm able to meet the exception number 1. And of course, number 2 is a fishing application. Now, what about supporting it? It says horizontal runs. So this is securing, and we secured it, fastened it in place, and we've got that covered. Now let's talk about supporting. It says horizontal runs of EMT supported by openings through framing members at intervals not greater than 10 feet and securely fastened within 3 feet of terminal points shall be permitted. So this is where we run it through metal or even wood, believe it or not, wood framing members. It is considered supported as it runs through there, okay? And so, again, it reminds us that, again, horizontal runs in EMT supported by openings through framing members at intervals, and as long as these intervals of these framing members don't go more than 10 feet, and most framing members will not. There'll either be 18 inches on center or 24 on center in commercial, so you're not going to have that issue. But just in case, if you ran it through framing members, you can't go more than 10 feet. If you do, then the framing members aren't considered supporting it, and you're going to have to add some kind of support to it. Okay, and again, it's still not required. The application where we're talking about where we still have the allowance, we're going to terminate within 3 feet. Then we're okay. Then we don't have to do anything extra in the horizontals. Okay, we don't have to add something as long as we're not more than 10 feet, and we're still terminating it within fastening it within 3 feet of the termination. Then we're good to go. 358.42, couplings and connectors. It says coupling and connectors used with EMT shall be made up tight, okay? Where buried in masonry or concrete, they shall be concrete tight type. Where installed in wet locations, they shall comply with 314.15. All right, and 314.15, if you don't remember, over in Article 314, deals with damp and wet locations. Okay, so that basically talks about where it says, and I'll read it to you so you understand, because it makes reference to 314.15 for damp and wet locations. It says, in damp and wet locations, boxes, conduit bodies, outlet box, hoods, and fittings. And remember, we were talking about, we were looking at it, we were talking about 358.42, so we're obviously talking about couplings and connectors. So the fittings are coupling and connectors. Shall be placed or equipped so that to prevent moisture from entering or accumulating within the box, conduit body, or fitting. Boxes, conduit bodies, outlet box hoods, and fittings installed in wet locations shall be listed for use in wet locations. Okay, so that's the main driver. We want to make sure in a wet location, they need to be listed for wet location. Compression type, those type of things. If you're going to install EMT in that location, then the couplings and the connectors have to be rated for that location. I think you probably already know that, but we just want to make sure we cover it so that you get a good idea. All right, next one we're dealing with is 358.56. Let's talk about splices and taps, okay? It says splices and tabs shall be made in accordance with 300.15. So what does that say? What are we trying to say here with this application? Because you and me both know that you can't put splices and you can't put taps in a raceway, okay? But we have to step back, because when we say raceway, we can have splices and taps in many cases inside of things like wireways, and that's a whole different subject. But when we make reference back to 300.15, we have to look at the portion of it that says, and under 300.15, it's the third paragraph, it'll say where the wiring method is a conduit, tubing, and then it goes on to various types of cable. It says that a box or conduit body shall be installed at each conductor splice point, outlet point, switch point, junction point, termination point, or pull point, unless otherwise permitted in 300.15A through L. And nowhere in here is going to give me the permission to put splices inside of a tubing system, since we're talking about EMT. Not going to embed them inside of there. No Western Union knots, none of that kind of crap. You can't put them in there, okay? All right, so if you've got splices, if you got taps, if you're running EMT, then you're going to have a junction box or something, a cabinet or whatever, to be able to make those splices or make those taps. You're not going to do it inside of an EMT, obviously. You're not going to fix a damaged wire and then pull it inside of the tubing and hope nobody ever finds out. Hopefully you never do something like that. Now, let's move on to 358.60, and we'll try to round this thing out. This is dealing with grounding. EMT shall be permitted as an equipment grounding conductor. We kind of saw that when we read the definition. EMT was tested. It's been tested. I think it was called the Gemini tests that were done. And anyway, the whole concept is that EMT is very effective as an equipment grounding conductor. When you use approved fittings, everything gets done right, it's fine. Many people require you to pull versus specification. They'll say you got to pull in a wire type. They just want that extra assurance. That's fine. But EMT, if you're ever in a pinch and you didn't have a raceway field calculation done right and you had a wire type equipment ground in there and you're just barely over the limit, maybe you do your calculation when you pull out that equipment grounding conductor and then reevaluate your raceway fill, and you might see that if I use the actual EMT as an equipment grounding conductor, I'm okay. And that might save you in a pinch. Okay, and I don't have to size that equipment grounding conductor. I don't have to utilize 250-122. Now, again, I'm a wire and cable guy. I'm not going to sit over here and cheer the kudos for the conduit folks or the tubing folks, okay? I love them because they protect my wire, but at the end of the day, this is just giving you an allowance to use the EMT as an equipment grounding conductor, not a requirement to use the EMT as an equipment grounding conductor, okay? Just want to make it clear. All right, then lastly, we're going to end up in part 3 with the construction specifications, pretty much done by the manufacturer, so we're going to end on that. It says 358.100. It says construction. It says EMT shall be made of one of the following. It'll tell you. It'll be steel with protective coating. And see, this almost tells you right away when somebody says, wait a minute, I can't install EMT in the ground. Well, if you go over here and look, that the steel EMT, ferrous, is required to have a protective coating. It says it right here. So it can go in the ground. It can go in concrete, okay? Aluminum. It can be made of aluminum, and there's many manufacturers now. Well, I shouldn't say many. There's 2 manufacturers that I know of. I think one's called American Tubing or something like that, but they make EMT. They actually might call themselves American Conduit, but they know that tubing's a tubing because they also make aluminum intermediate or rigid too, which is light as heck. You'd be surprised. Anyway, so it's steel with a protective coating, so it's inherently going to have that as part of its UL requirements. Aluminum and, of course, stainless steel, because you've heard me refer to stainless steel and you've heard me refer to steel and all that. So all of these are okay to be used as a material for making EMT, electrical metallic tubing. And then lastly, 358.120, the markings. It says EMT shall be clearly and durably marked at least every 10 feet as required in the first sentence of 110.21a. And usually that marking can be a label, it can be a stamp, an actual impression stamp that lets you know about every 10 feet, it's going to give you its marking requirements in accordance with 110.21a. Okay, so that pretty much covers EMT. It's really easy to work with. A lot of people can do some really pretty work with EMT. It is a thin wall. It can kink very easy if you don't know what you're doing or you try to do too many bends. That's why we have that bending requirement that says, hey, wait a minute. If you're going to do really tight radius bends in the field, you need to be careful because you need to make sure that the tubing, the value or the actual radius of the curve through the center line of the tubing is not less than what's shown in Table 2, Chapter 9 for one shot and full shoe bender. Normal bending, 90s, 45s, that's never going to come into play. You never have to worry. But if somebody tries to make this ultra tight bend with EMT, just be very careful because you can't do it. It's obviously going to kink it. And if you kink it, then you've actually reduced the internal diameter and you got to start over again. Throw it to the side, start something new. Okay. Well, that was kind of an overview of dealing with Article 358. Dealing with electrical metallic tubing. Hopefully you got something out of that. Please visit our website, masterthenec.com. Hopefully you listen to our podcasts and videos on electricianlive.com. Join us on our YouTube channel, youtube.com/masterthenec. Hunt for us on Facebook. Just go to Facebook and look for Master the NEC. If you're preparing for an exam, just hunt for Master the NEC exam prep, and we'll help you out. So thanks for listening. Until next time, folks, stay safe. God bless. You've been listening to Electrician Live with your host, Paul